This video demonstrates the front-end interface of our Streamlit-based geospatial data validation system. After downloading the system from GitHub, we can directly launch it by running Streamlit run in the terminal. Once the dashboard is started, users can select both the dataset type and the file format to upload. The available dataset types include suburbs, blocks, roads, buildings, and floors, and the supported file formats are GeoJSON, CSV, XML, and KML. After selecting the dataset type and format, the system automatically loads the corresponding validation rules. Users can then choose which rules to execute. If the user selects Auto, it means that all validation rules for that dataset type will be executed. Next, let's upload the dataset. In this demo, we use a block dataset in CSV format. Once the upload is complete, the system first displays a preview map showing all geometries in the dataset. Select Geometry column is used to choose which column in the dataset contains the geometric data. CRS preset provides quick options for selecting the coordinate reference system. If the desired CRS is not listed, it can be entered manually in CRS of Geometry column. To make visualization clear, we provide several adjustable sliders for map rendering. Max features for geometry preview, for example for huge datasets, limits the number of features drawn to avoid lag when previewing large datasets. Fill opacity adjusts the transparency of polygon fill colors. For example, 0 means fully transparent and 255 means fully opaque. Border width adjusts the border thickness in pixel, and border opacity controls the transparency of polygons or line borders. After reviewing the preview, clicking Run Validation triggers the backend to execute the selected rules. Validation results are then displayed in real time on the front-end interface. The system reports which features contain errors and summarizes the number of violations per rule. In this example, the validation report shows that there are 7 errors detected in the block dataset. The validation results are also visualized interactively on the PyDeck map. Users can explore the map to identify issues such as invalid geometries. Clicking a feature on the map reveals its detailed attributes and error description in the table below. Finally, users can export the validation report as a CSV file by simply clicking the download button. When we keep the same data but change the file format to KML, XML, or GeoJSON, the system still runs the same validation rules, and the output results remain identical, showing that all file formats are handled consistently. We also set up several parameter data frames, taking the minimum short-edge threshold as an example. When we adjusted the parameter from 1 to 2, the errors clearly increased. But when we changed it back, some previously errors were corrected and turned green. After demonstrating the overall workflow, we also turned parameters for different dataset types. In the building dataset, certain rules have adjustable tolerance parameters. Overlap tolerance, for example, which is defaulted as 0.05, means that if 2 buildings' boundaries overlap by less than 0.05 square meters, it will not be counted as an error. These controls allow users to fine-tune rule sensitivity according to dataset precision. That concludes the demonstration of the system's front-end interface. Next, we move on to the database module of the system. By running Streamlit run code, we can open the Registry viewer to inspect the stored validation history. The database records validation results by dataset type, and for each type, It stores every dataset uploaded and all of its validation runs. This allows users to review historical validation results and track changes over time.